The first of today's topic is angle bisectors. Lesson 5.1, angle bisectors, and then incenters is in lesson 5.2. Prove that the point of concurrency of the angle bisectors of a triangle is called the incenter, which we will find when we do our Desmos activity, is equidistant from the sides. We're going to use the angle bisector theorem to solve problems. Here is the angle bisector theorem. P implies Q. If a point is on the bisector of an angle, okay, we have a point, it's on the bisector, the angles are marked congruent, then the point is equidistant from the sides of the angle. So if segment AD bisects the angle BAC, ray AB is perpendicular to segment BD and ray AC is perpendicular to segment CD, then segment BD is congruent to segment DC. Converse, other way around. If a point is in the interior of an angle and equidistant from the sides of the angle, then the point's on the angle bisector. There we go. If the length of segment BD is equal to the length of segment CD, ray AB is perpendicular to segment BD and ray AC is perpendicular to segment CD, then ray AD bisects angle BAC and angle BAD is congruent to angle CAD. Write an equation and solve algebraically for the value of x. So we have an angle bisector, so those must be equal. Set them equal to each other. 4x plus 30 equals 9x minus 5. Move the smallest x, so subtract 4x on both sides of the equation. We get 30 equals 5x minus 5. Add 5 to both sides. 35 is equal to 5x. Divide by 5 and x is 7. Number 2. Find the value of x. This time we know that those two segments are congruent and perpendicular to the sides of that angle, so those must be congruent angles. That must be an angle bisector right there in the middle. So 5x minus 11 equals 8x minus 41. Move the smallest guy, so subtract 5x on both sides. Don't lose your negative. That minus 11 comes down as negative 11, and 8x minus 5x is 3x. Bring down your minus 41, and then get rid of it by adding 41 to both sides. So when we combine like terms on the left-hand side, we get 30 equals 3x. Divided by 3x is 10. Number 3, write an equation and solve algebraically for the value of x, then find the designated length. We're trying to find the length of segment AD. We have to find x first. Looks like we have an angle bisector, and we're going to know that those two are congruent to each other because the segments are perpendicular to the sides of the angle, and we have an angle bisector. So let's write our equation. 13x minus 4 equals 8x plus 11. Move the smallest x, so subtract 8x on both sides. We get 5x minus 4 is 11. Add 4 to both sides. 5x is 15. We're going to get x is 3. Length of segment AD, we have an expression for it. It's 13x minus 4. So we just need to plug the value we just found for x in place of x and calculate. And the length of segment AD is 35. Number 4, this time we're going to find an angle measure. So we have segments that are perpendicular to sides. Those two triangles are going to be congruent by HL. That's how come the angles are actually equal to each other. So we did kind of a little verbal proof of why this works. 8x minus 32 equals 3x plus 3. Move the smallest x, subtract 3x on both sides. 5x minus 32 is equal to 3. Add 32 to both sides. 5x is 35 and x is going to be 7. Now find the measure of angle XWZ, which is 8x minus 32, but technically they're the same. Put the value of x, 7, in place of our x and calculate. And the measure of that angle is 24 degrees. That is the end of part 1, angle bisectors.